All right, let's get into it. We're going to talk about what might be one of the most important relationships in the entire universe. Think of it like a cosmic romance, a story between two elements, carbon and oxygen. And believe it or not, how this love story plays out, well, it literally decides what kind of planets get created. I know, a cosmic romance? It sounds a little out there, right? Almost like something from a sci-fi novel. But here's the thing. It's not just a cool metaphor. This powerful attraction, this preference that carbon and oxygen have for each other, it's pretty much the number one thing that determines the geology of any rocky planet. And we're not talking about some small, minor effect here. I mean, the source material puts it beautifully. These are gases that literally shape planets. The whole planet. That's the kind of power we're dealing with. So it kind of begs the question, right? Where did these two cosmic superstars, carbon and oxygen, even come from in the first place?
Well, that brings us to our first part. They were forged in dying stars. To really get this story, you have to rewind the clock, way back to the very beginning, to these giant cosmic furnaces, where our two main characters were born.
So right after the Big Bang, the universe was, well, kind of boring. You basically just had hydrogen and helium floating around. That's great if you want to make a gas giant like Jupiter, but for rocky planets like Earth, no way. You need heavier stuff. And that heavier stuff, we're talking carbon, oxygen, silicon, it was all cooked up inside the super hot cores of dying stars, these huge red giants. Then, when these stars went out, they blasted all those new ingredients out into space, basically seeding the cosmos with the raw materials for new stars and, you guessed it, new planets. But here's where the drama really starts. As all this new material started clumping together in these giant clouds, getting ready to form new solar systems, carbon and oxygen, they just couldn't stay away from each other. They have this incredible attraction. They always find each other first, locking each other up in a chemical bond. It's like they're the main couple at the dance, and everyone else, all the other elements, just have to wait around and see who's left over. And that little drama, that's what leads us to the absolute core of this whole thing, the defining ratio. It's kind of wild to think about, but the entire fate of a solar system can boil down to one simple ratio. It's like cosmic chemistry destiny all in one number. Okay, so what is this magic number? It's all about this variable, y. And y is just how much oxygen you have compared to how much carbon. That's it. And the key number here is 2. Why 2? Well, think about carbon dioxide, CO2. You need 2 oxygen atoms to grab 1 carbon atom and form that really stable molecule. So depending on if you have more or less than that 2-to-1 ratio, the entire future of your rocky planets goes down a completely different path. So here you can see it laid out visually, the 2 roads this cosmic romance can take. Picture that big cloud of gas and dust starting to cool down. The first thing that happens, all the carbon and oxygen atoms make a mad dash for each other to pair up. Let's look at what happens next. So on one hand, you've got scenario 1. Here, you have way more oxygen than you need to pair up with all the carbon. So every single carbon atom gets snatched up, and you're left with a bunch of extra oxygen just floating around. But in scenario 2, it's the other way around. You've got more carbon than oxygen. So this time, all the oxygen gets used up. And what's left over? A whole lot of carbon. And this is the crucial part. The planets are built from the leftovers. And this isn't some far-off, abstract idea. It's the story of our own home. We are literally living on a planet made from the leftovers of this cosmic chemical reaction. So, yeah, let's talk about our world, a world of leftovers. Turns out, in our little corner of the galaxy, we had a scenario 1 situation. There was a lot more oxygen than carbon. So once all the carbon was bonded and out of the picture, all that leftover oxygen had to find a new dance partner, and it found one, silicon. They got together to form silicates, which is just a fancy word for the rock that makes up Earth and Mars and Venus. We live on a silicate world. You know, this is actually super useful for scientists looking for other Earth-like planets. They can just look for star systems that had that same oxygen-rich recipe to start with. And when we talk about oxides and silicates, don't just picture a bunch of letters and numbers from a chemistry class. Look at this. This is real. These are iron oxides. The same fundamental chemistry that built the crust of our planet is what gives these pigments their rich, earthy colors. It's beautiful, right? Our world is literally painted with the leftovers of that ancient cosmic romance. But wait a second. You might be thinking, what about us? We're made of carbon. So where did our carbon come from? Well, the carbon that makes you and me, it's all just borrowed. We pull it out of the atmosphere, live our lives, and eventually it goes back. The source material has this amazing phrase for it, calling us a living crust on this silicate world. We're just a tiny, temporary part of this huge cosmic cycle.
Okay, so we've got a pretty good handle on how our world came to be. Now for the really fun part. Let's speculate a little. Let's take everything we've learned and use it to imagine what the other outcome would look like. Let's talk about some truly alien worlds. So let's flip the script. What if you had a solar system that was born from scenario 2? What if, after all the oxygen was used up, the leftover element was carbon? What kind of planet would you get then? Well, that leftover carbon would also find silicon. But instead of forming silicates, they'd form silicon carbide. And that is a totally different beast. Instead of a rocky world like Earth, you would get a carbide world. I mean, just try to imagine that. Mountains made of a material so hard and sharp, we use it to make sandpaper and industrial cutting tools. That's a fundamentally wildly different kind of planet. And that just opens up a huge, fascinating question, doesn't it? What would life even look like there? I mean, with a totally different geology, a different atmosphere, could life even exist? And if it did, what would it be like? And that really brings us to the perfect final thought, which comes straight from the source material. They ask, wouldn't this make an incredible setting for some new science fiction? And yeah, it's such a great question to end on. It just goes to show you that the chemistry of the universe isn't just some dry, dusty science. It's a script for an infinite number of stories and possibilities. And it all starts with that simple cosmic romance between carbon and oxygen.